Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Chapter 4, Python Programming Fundamentals, Part 2, for the Class 11 students of Computer Science. In this video, we are going to discuss about the usage of Python data types, mutable and immutable data types, keywords in Python, expressions and operators. So let's dive in and get started. Python has several built-in data types that can be used to store different kinds of information. Here are some of the most common data types. First data type is integer called int is used to represent whole numbers, positive or negative. Next data type is float is used to represent decimal numbers, with a floating point precision. Next data type is boolean also called bool is used to represent true or false values. Next data type is string called str, is used to represent text or a sequence of characters. Next data type is list, used to represent a collection of items, ordered and changeable, meaning it can be modified. Example, if we store the names of students of a class in a list, then it is easy to update the list when some new students join or some leave the course. Next data type is tuple, used to represent a collection of items, ordered and unchangeable, meaning, when we do not need any change in the data. Example, names of days in a week. Next data type is set, used to represent a collection of unique items, unordered and unindexed. Next data type is dictionary, used to represent a collection of key-value pairs, unordered and changeable. Dictionaries can be preferred if our data is being constantly modified or we need a fast lookup based on a custom key or we need a logical association between the key-value pair. Example, a mobile phone book is a good application of dictionary. Now, we discuss about the type function. The type function in Python can be used to determine the data type of a particular variable or value. In example 1, x equals 5, assigns the value 5 to the variable x. Next line uses the print function to output the result of the type function applied to the variable x. The type function returns the data type of the object it is called with. So, the output of the print statement is class int. This output indicates that the type of the object stored in the variable x is an integer. In Python, an integer is a whole number without any decimal places. In example 2, y equals 3.14 assigns the value 3.14 to the variable y. Next line uses the print function to output the result of the type function applied to the variable y. The type function returns the data type of the object it is called with. The output of the print statement is class float. This output indicates that the type of the object stored in the variable y is a floating point number. In Python, a floating point number is a numeric type that represents numbers with fractional parts. It is indicated by a decimal point. In example 3, z equals hello assigns the string hello to the variable z. In Python, strings are enclosed in either single quotes or double quotes. Next line uses the print function to output the result of the type function applied to the variable z. The type function returns the data type of the object it is called with. The output of the print statement is class str. This output indicates that the type of the object stored in the variable z is a string. In Python, a string is a sequence of characters enclosed in quotes. In example 4, a equals true assigns the Boolean value true to the variable a. In Python, Boolean values can either be true or false. They represent the two possible states of truth. Next line uses the print function to output the result of the type function applied to the variable a. The type function returns the data type of the object it is called with. The output of the first print statement is class bool. This output indicates that the type of the object stored in the variable a is a Boolean. In Python, Boolean is a built-in data type used to represent logical values. Next statement is b equals false. This line assigns the Boolean value false to the variable b. Next line uses the print function to output the result of the type function applied to the variable b. The output of the second print statement is class bool, indicating that the type of the object stored in the variable b is also a Boolean. Next statement c equals 10 greater than 5, line assigns the result of the expression 10 greater than 5 to the variable c. The expression 10 greater than 5 evaluates to true since 10 is greater than 5. Next line uses the print function to output the result of the type function applied to the variable c. The output of the third print statement is class bool, indicating that the type of the object stored in the variable c is a Boolean. You should note the point that the Boolean argument should have t, capital letter, for true and f, capital letter, for false. Otherwise, it will generate an error. In example 5, d equals 3.2 plus 1.5j, assigns the complex number 3.2 plus 1.5j to the variable d. In Python, complex numbers are represented by a real part followed by an imaginary part, where the imaginary part is denoted by the suffix lowercase j or uppercase j. Next line uses the print function to output the result of the type function applied to the variable d. The output of the print statement is class complex. This output indicates that the type of the object stored in the variable d is a complex number. In Python, the complex type is used to represent numbers with both a real and an imaginary part. Now, look at the right side. We can also write the code as print type of 5, so the output is displayed class int. Here we didn't assign any variable, we found the type of the given integer number directly in the print statement. Likewise, we can code for all other data types also. In Python, data types can be classified as either mutable or immutable. A mutable data type is one whose values can be changed after they are created. Mutable data types in Python include lists, dictionary, set, etc. Here's an example that demonstrates the mutability of a list. First line, my_list equals 1, 2, 3, creates a list containing the elements 1, 2, 3, and assigns it to the variable my_list. In Python, lists are ordered, mutable collections of objects enclosed in square brackets. In the second line, my_list of 0 is equal to 4, modifies the value at index 0 of the my_list list. It assigns the value 4 to the first element of the list. Look at the table. In Python, lists are 0 indexed, so index 0 refers to the first element 1. It assigns the value 4 to the first element of the list. Next line of the code uses the print function to output the contents of the my_list list. The output of the print statement is 4, 2, 3. This output indicates that the first element of the my_list list has been modified from 1 to 4, while the other elements remain unchanged. An immutable data type is one whose values cannot be changed after they are created. Any attempt to modify an immutable value will result in a new value being created. Immutable data types in Python include int, float, string, bool, complex, and tuples. Here's an example that demonstrates the immutability of a string. Example 1. S equals hello assigns the string hello to the variable s0 equals h. This line attempts to modify the first character of the string s to uppercase h. However, since strings are immutable, this operation is not allowed. As a result, when you execute the code, it will raise a type error indicating that the string object does not support item assignment. The error message will be similar to type error, str object does not support item assignment. In example 2, s1 equals hello assigns the string hello to the variable s1. Next line, s2 equals s1.upper, calls the upper function on the string s1 and assigns the result to the variable s2. The upper function returns a new string where all the characters are converted to uppercase. Next line, print s1, uses the print function to output the value of s1. The output of the first print statement is hello. This is because the upper function does not modify the original string s1. It creates a new string with uppercase letters and assigns it to s2, leaving s1 unchanged. Next line, print s2, uses the print function to output the value of s2. The output of the second print statement is uppercase hello. This is the result of calling the upper function s1 and storing the uppercase version of the string in s2. Note that once an immutable object loses its binding to its variable, the Python interpreter may delete the object and release the allocated memory to be used for other tasks. This process of automatic memory management is called garbage collection. Let's discuss about the keywords in Python. Keywords in Python are reserved words that have a special meaning in the language. These words cannot be used as variable names, function names, or any other identifiers. For checking or displaying the list of keywords available in Python, we have to write the following two statements. Import keyword, print, keyword.kwlist. You can see, a list of all the keywords in Python are displayed in this picture. These keywords have a specific meaning and purpose in Python. Example, if and else are used for conditional statements, while is used for loops, def is used to define functions, and so on. In Python, an expression is a combination of one or more values, operators, and/or function calls that can be evaluated to produce a result. Expressions can be used to perform a wide variety of calculations and manipulations on data. Here are some examples of simple expressions in Python. X equals 10 is an assignment expression, y equals x plus 5 is an addition expression, and z equals x plus y, asterisk 2 is a complex expression. We have a more complex expression that adds x and y, multiplies the result by 2, and assigns the final value to the variable z. Expressions can also include function calls, which can be used to perform more complex calculations or manipulations on data. In this example, we're using the math.sqrt function to calculate the square root of the variable x and assign the result to the variable y. The math module contains a variety of mathematical functions that can be used in expressions. In Python, expressions can also include conditional statements, loops, and other control structures to perform more complex operations. Overall, expressions are a powerful tool in Python for working with data and performing calculations and manipulations on that data. Type conversion, also known as typecasting, is the process of converting a value from one data type to another. In Python, there are several built-in functions that can be used for type conversion. Here are some common examples of type conversion in Python. First one is int function. The int function can be used to convert a value to an integer data type. In this example, we're converting the floating point value 5.5 to an integer using the int function. The resulting value is 5. Next is the float function. The float function can be used to convert a value to a floating point data type. Now, look at the example. X equals 5, y equals float of x, print, y. In this example, we're converting the integer value 5 to a floating point number using the float function. The resulting value is 5.0. Next is the string function. The str function can be used to convert a value to a string data type. For example, x equals 5, y equals str of x, print, y. In this example, we're converting the integer value 5 to a string using the str function. The resulting value is the string 5, with quotation marks. Next is the bool function. The bool function can be used to convert a value to a Boolean data type. For example, x equals 5, y equals bool of x, print, y. Since x has a value of 5 which is non-zero, the bool function returns true. Therefore, the value of y becomes true. The statement print of y outputs the value of y, which is true, as output. Next is the chr function. The chr function can be used to convert a value into a character data type. For example, x equals chr of 65, print x. In the given code, the statement x equals chr of 65 assigns the character represented by the Unicode value 65 to the variable x. The chr function in Python takes an integer representing a Unicode point and returns the corresponding character. In Unicode, the code point 65 corresponds to the uppercase letter A. Therefore, chr of 65 returns the character A, which is then assigned to the variable x and prints as output. In Python, operators are special symbols or functions that are used to perform operations on one or more operands. An operand is a value or variable that an operator acts upon. Operators, when applied on operands, form an expression. Same operator can behave differently on different data types. Here are some examples of commonly used operators in Python. First one is the mathematical or arithmetic operators, are used to perform various mathematical operations on numeric data types such as integers and floating point numbers. These operators include addition, which adds values together. In example 1, we first assign the value 10 to the variable x, and then assign the value 3 to the variable y. After that, we use the print function to output the sum of x and y, which is 13, as output. In addition, second example, we are going to learn about concatenating strings. Strings can be added together with the plus operator. To concatenate the string hello world, give the statement using the concatenation operator, plus. Now look at the Python code. Print hello plus world concatenates the two string literals hello and world using the plus operator. In Python, when you use the plus operator with two strings, it performs string concatenation, joining the two strings together. So, the output will be hello world, without spaces. Next arithmetic operator is subtraction. It subtracts the second value from the first value. In example 1 of subtraction, we assign the value 10 to the variable x and the value 3 to the variable y. Then, the expression x, y subtracts the value of y from x, resulting in 7. Finally, the print function outputs the result, 7, to the console. In example 2 of subtraction, we assign the value 30 to the variable x and the value 80 to the variable y. Then, the expression x, y subtracts the value of y from x, resulting in -50. Finally, the print function outputs the result, -50, to the console. Next arithmetic operator is multiplication, which multiplies two values together. In example 1 of multiplication, we assign the value 10 to the variable x and the value 3 to the variable y. Then, the expression x asterisk y multiplies the values of x and y, resulting in 30. Finally, the print function outputs the result, 30, to the console. In example 2 of multiplication, we have string multiplication. Here, the code print, hello asterisk 5, uses the asterisk operator to repeat the string hello 5 times and then prints the result. The string hello is multiplied by 5 using the asterisk operator. This operation results in the string being repeated 5 times, generating hello 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 as output. Next arithmetic operator is division, which divides the first value by the second value. In example 1 of division, the code performs division between x and y using the slash operator and then prints the result. We assign the value 10 to the variable x and the value 3 to the variable y. Then, the expression x/y divides x by y, resulting in 3.333333333333333335. The result is a floating point number because at least one of the operands is a float. In this case, x is an integer and y is an integer, but the division operation automatically promotes the result to a float. Next arithmetic operator is remainder or modulus. It returns the remainder of the division of the first value by the second value. In example 1 of remainder or modulus, we assign the value 10 to the variable x and the value 3 to the variable y. Then, the expression x%y calculates the remainder when x is divided by y, resulting in 1. In this case, 10 divided by 3 equals 3 with a remainder of 1. Finally, the print function outputs the result, 1, to the console. Next arithmetic operator is exponentiation, which raises the first value to the power of the second value. In example 1 of exponentiation, we assign the value 10 to the variable x and the value 3 to the variable y. Then, the expression exponentiation y, raises x to the power of y, resulting in 1000, since 10 raised to the power of 3 is 1000, it prints 1000 as output. Next arithmetic operator is integer division or floor division, which performs integer division and returns the largest integer value that is less than or equal to the result. In example 1 of integer division or floor division, we assign the value 10 to the variable x and the value 3 to the variable y. Then, the expression x floor division y performs floor division, which divides x by y and rounds the result down to the nearest whole number. In this case, 10 divided by 3 equals approximately 3.33333333333333335, but since floor division rounds down, the result is 3. Finally, the print function outputs the result, 3, to the console. In example 2 of integer division or floor division, we assign the value 7.0 to the variable x, a floating point number, and the value 2 to the variable y, an integer. Then, the expression x floor division y performs floor division, which divides x by y and rounds the result down to the nearest whole number. In this case, 7.0 divided by 2 equals 3.5, but since floor division rounds down, the result is 3.0, represented as a floating point number. Finally, the print function outputs the result, 3.0, to the console. In example 3 of integer division or floor division, we assign the value -9 to the variable x and the value 2 to the variable y. Then, the expression x floor division y performs floor division, which divides x by y and rounds the result down to the nearest whole number. In this case, -9 divided by 2 equals -4.5, but since floor division rounds down, the result is -5. Finally, the print function outputs the result, -5, to the console. An operator can be termed as unary or binary, depending upon the number of operands it takes. A unary operator takes only one operand and a binary operator takes two operands. In this example, in the expression -5*3 plus 6 minus 1, the first minus sign is a unary minus and the second minus sign is a binary minus. The multiplication and addition operators are binary operators. Arithmetic operators in Python have different precedence levels, which determine the order in which the operations are performed. The precedence of arithmetic operators in Python is as follows, from highest to lowest. First precedence, parentheses can be used to group sub-expressions and override the default order of evaluation. Exponentiation operator has the highest precedence among the arithmetic operators. Multiplication, division, and modulus, these operators have the same precedence and are evaluated left to right. Addition and subtraction, these operators have the same precedence and are evaluated left to right. Here's an example that demonstrates how the order of operations is determined by operator precedence. In the expression, x equals 5 plus 10 * 2 exponentiation 2/4, first, the exponentiation operator is evaluated. In this case, 2 to the power 2 equals 4. Next, the multiplication operator is evaluated. 10 times 4 equals 40. Then, the division operator is evaluated. 40 divided by 4 equals 10.0. Note that when dividing two integers in Python 3, the result is a float. Finally, the addition operator, plus, is evaluated. 5 plus 10.0 equals 15.0. Therefore, the final value of x is 15.0. When you print x, the output will be 15.0. Relational operators, also known as comparison operators, are used to compare two values or variables and return a Boolean value, true or false, based on the comparison. In an expression, comprising both arithmetic and relational operators, the arithmetic operators have higher precedence than relational operators. The syntax is expression 1, comparison operator, expression 2. In Python, the following relational operators are available: equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. Here are some examples of how these relational operators can be used. Consider variable x and y are assigned the values 5 and 10 respectively for all these 6 Python statements. In the first statement, it compares the values of x and y using the equality operator. Since the value of x is 5 and the value of y is 10, the expression x equals y evaluates to false. This is because x and y have different values. In the second statement, it compares the values of x and y using the not equal to operator. Since the value of x is 5 and the value of y is 10, the expression x not equal to y evaluates to true. This is because x and y have different values, and the not equal to operator returns true when the values are not equal. Therefore, when you print the result, the output will be true. In the third statement, it compares the values of x and y using the less than operator. Since the value of x is 5 and the value of y is 10, the expression x less than y evaluates to true. This is because 5 is less than 10. Therefore, when you print the result, the output will be true. In the fourth statement, it compares the values of x and y using the greater than operator. Since the value of x is 5 and the value of y is 10, the expression x greater than y evaluates to false. This is because 5 is not greater than 10. Therefore, when you print the result, the output will be false. In the fifth statement, it compares the values of x and y using the less than or equal to operator. Since the value of x is 5 and the value of y is 10, the expression x less than or equal to y evaluates to true. This is because 5 is less than or equal to 10. Therefore, when you print the result, the output will be true. In the sixth statement, it compares the values of x and y using the greater than or equal to operator. Since the value of x is 5 and the value of y is 10, the expression x greater than or equal to y evaluates to false. This is because 5 is not greater than or equal to 10. Therefore, when you print the result, the output will be false. Relational operators are applied to strings also. When the relational operators are applied to strings, strings are compared left to right, character by character, based on their ASCII codes, and also called ASCII values. In the ASCII table, each character is assigned a unique numerical value. The lowercase letters have ASCII values ranging from 97 to 122 Z, while the uppercase letters have ASCII values ranging from 65 to 90 Z. In first example, it compares two string literals, lowercase hello and uppercase hello, using the less than operator. When comparing strings, Python uses the ASCII values of the characters. In this case, the ASCII value of lowercase h in hello is greater than the ASCII value of uppercase h in hello. Therefore, lowercase hello is considered greater than uppercase hello in lexicographical order. As a result, the expression hello less than hello evaluates to false. When you print the result, the output will be false. In the second example, it compares two string literals, goodbye and hello, using the less than or equal to operator. When comparing strings in lexicographical order, Python compares the characters from left to right based on their ASCII values. In this case, the first character of goodbye is G, while the first character of hello is H. Since G has a lower ASCII value than H, goodbye is considered less than hello in lexicographical order. Therefore, the expression goodbye less than or equal to hello evaluates to true because goodbye comes before hello in lexicographical order. In the third example, it compares two string literals, hello and hello, using the not equal to operator. In this case, both strings are identical, as they have the same sequence of characters. Therefore, the expression hello not equal to hello evaluates to false. The not equal to operator returns false when two values are equal, and true when they are not equal. Since the strings are equal in this case, the output will be false. In the fourth example, it compares two string literals, hello and hello, using the equal to operator. Since both strings have the same sequence of characters, the expression hello equal to hello evaluates to true. The equal to operator returns true when two values are equal, and false when they are not equal. In this case, the strings are indeed equal, so the output will be true. Logical operators in Python are used to perform logical operations on Boolean values. They are used in control statements and loops to make decisions based on the truth value of expressions. The three logical operators in Python are AND, returns true if both operands are true, and false otherwise. OR, returns true if at least one of the operands is true, and false otherwise. NOT, returns the opposite of the operand's truth value, reverses the state of operand or condition. Here are some examples of using logical operators. In the given example, it assigns the values 5, 10, and 5 to the variables x, y, and z, respectively. In the first print statement, it evaluates the expression x equal to z and y greater than x. The AND operator performs a logical conjunction. It returns true if both operands are true, and false otherwise. In this case, the expression x equal to z evaluates to true because x and z both have a value of 5. The expression y greater than x also evaluates to true because 10 is greater than 5. Since both operands of the AND operator are true, the overall expression x equal to z and y greater than x evaluates to true. In the second print statement, it evaluates the expression x greater than y or x equal to z. The OR operator performs a logical disjunction. It returns true if at least one of the operands is true, and false if both operands are false. In this case, the expression x greater than y evaluates to false because 5 is not greater than 10. The expression x equal to z evaluates to true because x and z both have a value of 5. Since one of the operands of the OR operator, x equal to z, is true, the overall expression x greater than y or x equal to z evaluates to true. Therefore, when you print the result, the output will be true. In the third print statement, it evaluates the expression not x equal to z. The NOT operator is a logical negation operator. It reverses the truth value of an expression. If the expression is true, NOT makes it false. If the expression is false, NOT makes it true. In this case, the expression x equal to z evaluates to true because x and z both have a value of 5. The NOT operator then negates the truth value of x equal to z. Since x equal to z is true, NOT x equal to z evaluates to false. Therefore, when you print the result, the output will be false. Logical operators in Python also have different precedence levels, which determine the order in which the operations are evaluated. The precedence of logical operators in Python is as follows, from highest to lowest. NOT. The NOT operator has the highest precedence among the logical operators. and. The AND operator is evaluated before the OR operator. Or. The OR operator is evaluated last. Here's an example that demonstrates how the order of operations is determined by operator precedence. X equals true or false and not true, print X. This expression follows the order of operations, precedence, in Python. The NOT operator has the highest precedence, so not true evaluates to false. Next, the AND operator is evaluated. False and not true evaluates to false because one of the operands, false, is false. Finally, the OR operator is evaluated. True or false and not true evaluates to true because one of the operands, true, is true. Therefore, the final value of X is true. When you print X, the output will be true. Shorthand or augmented assignment operators in Python are used to combine an arithmetic or bitwise operation, binary operation, with an assignment in a concise way. Instead of writing X equals X plus Y, for example, you can use the shorthand operator plus equals. These operators modify the value of the variable in place, rather than creating a new variable, and can be used with all of the basic arithmetic and bitwise operators. Here is a list of shorthand operators in Python, along with examples of their usage. First one is, plus equals, adds the right operand to the left operand and assigns the result to the left operand. Example 1. X plus equals 5 is equivalent to X equals X plus 5. Next one is, minus equals, subtracts the right operand from the left operand and assigns the result to the left operand. Example 2. X minus equals 5 is equivalent to X equals X minus 5. Next one is, asterisk equals, multiplies the left operand by the right operand and assigns the result to the left operand. Example 3. X asterisk equals 5 is equivalent to X equals X asterisk 5. Next one is, / equals, divides the left operand by the right operand and assigns the result to the left operand. Example 4. X / equals 5 is equivalent to X equals X / 5. Next one is, modulus equals, calculates the modulus of the left operand with the right operand and assigns the result to the left operand. Example 5. X modulus equals 5 is equivalent to X equals X modulus 5. Next one is, exponentiation equals, raises the left operand to the power of the right operand and assigns the result to the left operand. Example 6. X exponentiation equals 5 is equivalent to X equals X exponentiation 5. Next one is, integer division equals, performs integer division on the left operand with the right operand and assigns the result to the left operand. Example 7. X integer division equals 5 is equivalent to X equals X integer division 5. Membership operators in Python are used to test whether a value or a variable is a member of a sequence, such as a string, list, tuple, or set. Python provides two membership operators, in and not in. First, we will see how to use membership operators in strings. First one is, in operator returns true if a character or substring exists in the given string. Second one is, not in operator returns true if a character or substring does not exist in the given string. To use membership operators in strings, it is required that both the operands used should be of string type. Substring in string, substring not in string. In this example, it assigns the string hello, world, to the variable my_string. Then, it uses the in operator with the not operator to check if certain substrings are present or not in my_string. In the first print statement, world not in my_string checks if the substring world is not present in my_string. Since world is indeed present in my_string, the expression evaluates to false. In the second print statement, goodbye not in my_string checks if the substring goodbye is not present in my_string. Since goodbye is not present in my_string, the expression evaluates to true. Therefore, when you print the results, the output will be false for the first print statement, true for the second print statement. Identity operators in Python are used to compare the memory location of two objects. They check whether two objects are the same object or not. Python provides two identity operators, is and is not. First one is operator returns true if the left operand and the right operand refer to the same object in memory. That is, both variables are pointing to the same object. var1 is var2 results to true if id of var1 is equal to id of var2. Second one is not operator returns true if the left operand and the right operand does not refer to the same object in memory. That is, both variables are not pointing to the same object. var1 is not var2 results to true if id of var1 is not equal to id of var2. In example 1, it creates a list 1, 2, 3 and assigns it to the variable x. Then, it assigns x to the variable y. In the first print statement, it checks if x and y refer to the same object using these operator. Since both x and y refer to the same list object, the expression x is y evaluates to true. In the second part, a new list, 1, 2, 3, is created and assigned to the variable z. The print statement checks if x and z refer to the same object using these operator. However, even though x and z have the same values, they are separate objects in memory. Hence, the expression x is z evaluates to false. Therefore, when you print the results, the output will be true for the first print statement, false for the second print statement. In example 2, it assigns the strings hello and world to the variables a and b, respectively. Then, it checks if a is not the same object as b using the is not operator. Since a and b are different string objects, the expression a is not b evaluates to true. In the second part, two separate lists, 1, 2, 3, are created and assigned to the variables c and d. The print statement checks if c is not the same object as d using the is not operator. Since c and d are separate list objects even though they have the same values, the expression c is not d evaluates to true. Therefore, when you print the results, the output will be true for the first print statement, true for the second print statement. Thanks for watching. Watch the upcoming videos. Chapter 4, Python Programming Fundamentals, Part 3, which includes user input, user-defined functions, indentation in Python, rules and conventions for writing Python programs, comments, debugging. You can check the link in the description box below.